coming out and joining us today for today's topic, which is architecting your UI for maximum scalability and performance, in particular on the STM32 product line, so whether it's the MCU or the MPU side of things. So your today's speakers, like I said, I'm Scott Snider. I am the product marketing manager here at Crank Software for our Storyboard UI design and development tool. We also have on the line Soren Mikkelsen. He is with STM, and he is the business development engineer for graphics. As well as from Crank Software, we have Gary Clarkson. He is our field application engineer that's located in the EMEA region. So what are we going to be talking about today? Well, we're going to kind of jump into the STM32 product line and devices, and really kind of talking about what sets them apart from all the other products out there, and maybe giving you a little bit of kind of idea as to which product may be best for you. And then we're going to jump into an introduction as to who Crank Software is, and of course Storyboard, our UI design and development tool. And then talking about what makes Storyboard great for embedded UI development, maybe what makes it different from other solutions out there. And then we're going to jump into a live demo. So let's get things started. I'm going to hand things over to Soren.
Thank you very much, Scott. Hello, everyone. My name is Soren Mikkelsen, and I'm a business development engineer from STMicroelectronics, with special focus on graphics on STM32 and more specifically on graphics business in the Americas and high-performance MCUs running GUIs. For my part, I'll give you a short introduction to our hardware offerings on MCU and MPUs. But before, let me start with the GUI evolution, which has been going on for some years and is still continuing to evolve. As you all have seen, products are getting richer and embedding more richer HMIs, and users are always comparing, and I think myself too, compare products to my own smartphone with animations and all of this. And this trend is of course also pushing our microcontrollers in the direction of being more powerful and embedding high integration and connectivity, etc. So in ST, we have for many years been focusing on graphical user interfaces on microcontrollers, and also now we are focusing on MPUs with the STM32 MP1 series, which we'll come back to. These years has provided us with a large know-how of both hardware and software for running embedded GUIs to make sure we meet tomorrow's need for embedded GUIs. Scott, please go to next slide. So here you have an overview of our hardware portfolio, which ranges from Cortex M0s up to Cortex A7 now. In general, I would say STM32 can, all our STM32 could run a user interface. So the choice here really depends and comes down to what kind of display you want to use, what is the resolution, what is the color depth, the need of animation, full screen transition, and of course together with the required application and the operating system and so on. So with this lineup, I would say we range from very simple down to segment displays, low-end, mid-end resolution running low colors and 8, 16, 24, 32-bit 2D animations and so on, up to more high-end MIPI-DSI, LCD, 3D setups. So you really have a really strong setup here, offering being able to meet the most needs you could have for GUIs. For more advanced graphics, we have selected some STM32 embedded with embedded hardware acceleration for enabling more animations, more fluid UIs, doing alpha blending, video playback, and so on. And for this, I'll show you on the next slide. If you please go to the next slide. So with the stars, these are the series with what we call advanced graphics capabilities. So we have some STM32 M4s, STM32 F7, S87, the new series, and different L4s, and also the MP1. And of course, they give you a different level of performance, integration, embedded memory, package size, and so on. And all dependent on your needs, you could find a suitable package here. On top of our hardware, we have like Crank Software, who is one of our good partners for running a graphical user interface. And combined with our powerful hardware acceleration features like Chromart and OpenGL and so on, you can really achieve great performance and a really good user interface. I can show you here. Please go to next slide. It's a more complete overview of some of the selected STM32 products with advanced graphics. So if we dive more into these, our frequency ranges from 120 up to 480 on these specific MCUs, and up to 800 megahertz on the MPU, and on the A7, and you also have an M4. And the embedded memory ranges from very limited boot flash, having, let's say, down to 64 kilobytes, 128, all the way up to 2 megabytes of internal flash. And for the RAM part, you can find products embedding up to 1.4 megabyte. And for the frame buffer, you would have on these specific ones 1.1 megabyte for the frame buffer. So running a really powerful UI from internal RAM, not needing external RAM. And we also do support a wide range of display interfaces, so SPI interfaces, displays embedding RAM and parallel HH and so on, and also the more common RGB TFT through our LTDC and VPDSI interfaces also. So a wide range of choices here. And if you need more sophisticated UI, then we recommend you look at MCUs embedding Chromart, which could be a good choice here. And if you need video playback, then look at MCUs embedding motion JPEG. And for more specific on the hardware acceleration part, so in these STM32 products with advanced graphics capabilities, we have the Chromart accelerator, and this is a really powerful, efficient 2D image copying we can do here. Some transparency, alpha blending, direct memory access, pixel format management, and so on. So these operations, if you do this on the UI, it will offload the MCU if you need this to do other things. So for some UIs, you can actually experience a really low MCU load. As I mentioned before, we have the hardware JPEG codec for running a video playback. And last but not least, we have Chrome GRC, and this is an IP allowing you to save some RAM if you use round displays. So instead of writing the corners in the frame buffer, which is not visible for the users, we're not doing this, so you save around 10, 15, 20% of RAM. And sometimes this can be helpful if you need to fit an internal RAM or if you have a limited space of external RAM. So this is just to emphasize on two very important parts we have. So the first one is our cost optimized value lines. So our 8.7 and F7 series, we have what we call value lines. These are embedding the essential flash, so the boot flash. So with this setup, you'll need external RAM and external flash of your own choice. They are still embedding really good advanced graphics features for the Chromart and the TFT controller and so on, and there's a large package choice here. If we go in the other direction, embedding more memory, then we have the new 8.7A, 8.7B series. This is embedding 1.4 megabyte of internal RAM, and you have 1.1 for the frame buffer. So you can actually run an application with 480, 320, 24-bit without needing external RAM, and resolutions below that, and also 16-bit, of course, saving you BOM cost for not needing external RAM. This is also like the value line embedded in Chromart, JPEG codec, TFT controller, Chrome GSC. So a really powerful one, and a large package choice also. On this particular one, we have graphic support starting from QFP 64 pins. And here we have our STM32 MP1, which is our newest addition to the STM32 family. So the STM32 MP1 comes on top of the STM32 microcontroller series open the door for more for higher performance in terms of connectivity, multimedia, in combination with Linux, Android, and etc. So if you really need real 3D GPU stuff, this is a really good choice for you. With this additional STM32, our customers can build platforms ranging from M0s all the way up to H7s. So yeah, we really cover the whole range of UIs, I think. The STM32 MP1 embeds a dual-ARM Cortex A7 running up to 800 megahertz, and you have an M4 also running at 209 megahertz. So really combining the best of both worlds when it comes to Linux and real-time OSs. More specific on the graphical user interface, the MP1 embeds a 3D acceleration running at 533 megahertz, which support up to wide XGA resolution. This is around 2080 times 800 in resolution, around that. The LCD connectivity is either through, let's say, an EPDSI interface, 2 lanes, or you have a 24-bit parallel LTDC you can also interface your display with. So with this resolution, you can run simple GUIs and up to really high-end GUIs also needing 3D animations and other kind of things. As the MP1 comes in different flavors, it also comes without the 3D support. So if this is not needed, this could be a better choice for you, and you can still run a really good UI, which will use the MPU powers and the processor power instead of the GPU. If we go to the software environment part, we provide an open ST Linux distribution, Yocto framework plus tools, and it also leverages our rich STM32 Cube tool suite, which I hope a lot of you know about already, which is a really good software suite, and this is also being leveraging by the STM32 MP1. And if you want to try it out, the MCUs or the MPUs, and try it in combination with Crank, we have different Disco eval boards you can buy online, and I know there's a lot of great demos you can flash from Crank on these different kits, and you can probably ask in the chat which one could be relevant and where to find it. And you can also find really good support, online documentation, and you can visit our community asking questions on this if relevant. So I invite you all here, and yeah, we will do our best to support you here. Yeah, and this is a really great way of trying out Crank. That's it from my side on STM32 introduction. If you have any questions, please feel free to ask in the chat, and I will try and answer you, or I have my colleague Mike Hartman heading graphics in the Americas with us also, and he will also assist us here. Okay, thank you very much. I will hand it over to you, Scott or Gary.
There we go. So hopefully everybody's my screen advanced. Everybody's seeing what's saying Crank software right now. So yeah, so just before we jump into the live demo and I pass things off over to Gary, I just want to kind of quickly introduce you all to Crank software and Storyboard, like I said. So definitely, you know, if this is the first time you've never heard of Crank software before this presentation, I can guarantee that at some point in time that you probably have interacted with a product that is running a UI that was built using our UI development software, Storyboard. Because as you can see, we support a range of different industries, from smart home to industrial, and a range of different products. So just to let you know, Crank Software is a software and a services-based company that is headquartered in Canada. Our leadership team has an extensive background in embedded graphics and systems, with over 20 years of experience each within that world. We also have a large global customer footprint, from Fortune 500 companies to small organizations. So it doesn't really matter how large you are, or how small you are, how many products are you going to be a limited run, or is it going to be this mass consumer market? You know, we have different customers that we have worked with closely to make sure that they provide the best user experience possible for your customers. So we have over hundreds of millions of devices that are out there in the field running using a Storyboard built UI. And also we offer our customers access to a global distribution partnership network for global or localized support for your needs, to address your needs. So like I said, not only a software company where we built Storyboard, but we're also a services-based company. And what that means is that if you have the idea or the vision, but maybe don't have the in-house expertise, we have a team of app developers that can help you create that product, create that vision, take that vision, bring it to real life. It doesn't matter at what stage, whether it's just maybe helping with the design, maybe if you need a prototype created to really kind of advance the product with your executive management team. Maybe you've been building it yourself using Crank Software's Storyboard, but maybe you want to maybe have a second opinion, like how can it be further optimized? It doesn't matter what you need. We have the services and the team there to support you. So definitely, if you are maybe at a stage where you don't know where to begin, or you're trying to hire people, but you're having a hard time hiring those qualified people, reach out to us and find out how we can help you out today. So why did we create Storyboard? Well, definitely, like I said, when it comes to developing UIs for today's embedded products, things have really become increasingly more challenging. So like Soren was mentioned earlier, the user expectations have been elevated, right? Today's consumers really expect this intuitive and modern experience, especially with devices that have touch screens, because of the fact that every day we can reach into our pockets or our purses and we pull out this powerful device with a beautiful touch screen that provides the smooth, intuitive experience. So not only does it mean that for the physical hardware itself, but really the quality and the smoothness, or the overall user experience with its graphical user interface, has really set an expectation. In fact, the user experience has really quickly become a defining part of today's products, with its UIs being one of the main factors that today's products are being measured on, and what often drives the value consumers see in it, as well as their purchasing decision. Also, integrating evolutions in technology no longer only means making hardware decisions anymore, but really how can those technologies be incorporated into the user interface? And of course, anytime time is lost, or resources wasted, or coding changes need to occur, these all create delays in getting the product to market on time, and even sometimes on budget. So all of these have really made it increasingly challenging to really develop products with a UI in today's world. And that's why Storyboard was designed. It was really designed to remove the barriers or issues that are typically associated with UI design and development. So like I said, it's based upon over 2 decades of experience in designing and implementing embedded GUI solutions for a broad range of industries. So the founders of Crank Software really kind of, when they created Crank Software, they set out to build a solution that could help remove the inefficiencies that not only frustrated them, but their developer colleagues when it came to developing UIs for embedded devices. When it comes to Storyboard, what we often hear is powerfully simple yet sophisticated. That is what our customers tell us. It's easy to use interface really enables them to create UIs more quickly and more efficiently. So, and this is all because the unique architecture that the founders put into Storyboard. So they decoupled the front end UI design from the back end logic. What this really allows is the designer and developers to kind of work in parallel when it comes to building the UI application, thereby making Storyboard easier for you to get started early on the development of the UI. It really makes it easier to embrace design iterations, because let's face it, it's not a matter of if, it's a matter of when it's going to occur. And of course, helps reduce the complexity of developing UIs for an ever-evolving embedded hardware world, or even maybe embedded product lines that you may have, all helping and resulting faster time to market for your products. So let me break that down a little bit. So when it comes to really kind of helping accelerate development, UI development can be fast-tracked by starting the UI design in tools such as Photoshop or Sketch. And then once the overall UI look is ready, it can be imported in the storyboard. So, and then they become the building blocks for the UI. And then from there, UIs can be brought to life using Storyboard's integrated animation tool that allows you to create, edit, and review animations all directly within the tool itself, as well as critical usability testing or gaining stakeholder feedback by doing using its in-tool prototyping that can, and simulation tools that can be deployed on the physical hardware itself, or maybe onto a mobile device so you can take with you. Of course, once UI development begins, designers and developers can continue working in Storyboard's parallel workflow environment to really help remove the pain and struggle associated with iterations that naturally occur. Like I said, when it comes to UI design, everybody has an opinion, like whether that button should be bigger, smaller, over to the left, over to the right, should it be blue, should it be red? And so, you know, when you take it to that critical maybe usability testing, you're going to get a wealth of feedback back of it. So really, you know, making it easy to incorporate those changes is what the team set out to do. So you can easily introduce design changes that don't impact the progress or cause a complete teardown of code with Storyboard. It allows you to completely modify the UI look simply by, you know, again, the designer going back to Photoshop, making the changes in Photoshop and re-importing those Photoshop files back into, without having to create an entirely new application or overriding the prior development work that was done. Even more importantly, Storyboard provides this really unique tool called graphical compare and merge, which allows you to remain in control of those iterations throughout the entire process. What allows you to do is, as you import it, you can simply go through and select which changes you want to import, whether it's all of them or just a select few, really making it easier and a more efficient process when you have multiple users or multiple people really working on creating that UI. And then, you know, last but not least, with all the vast choices of hardware and operating system combinations that you have, you can guarantee that it's most likely that Storyboard created UIs will run on it. And that's because Storyboard was created to really provide a platform agnostic tool. So that way it really de-risks your projects by introducing this framework that easily supports technology and design changes at any point, really providing your UI with UI flexibility. So taking it up a notch from just, not only is it from scalability, allowing you to scale from MCUs to MPUs or vice versa, but allows you to have a portability. So allowing you to kind of swap out parts of your technology stack at any point in time. So maybe, for example, STMicroelectronics introduces a new powerful but more cost-effective MCU while you're partway through the development. You can easily take advantage of that, and as long as we support it, basically put that UI over to it and gain the benefits from the power and the cost savings for your overall BOM. And then of course you have reusability, which really allows you to embrace multiple product lines, that you create that UI once and you can scale it up, you can scale it down, and you can reuse it across different products. So really what it comes down to, what makes Storyboard different, is that we're not a code generation framework. And Gary will go into a little bit about that when he talks about it. So, you know, we're not about, you know, creating everything in C++ and then having to compile and having to rechange that code, which really allows you to lower the barrier to entry when it comes to UI software development. Also, like I said, that decoupling of the front-end UI from the back-end logic with a really well-defined data model and events API in between really provides a clean separation between the UI development and the hardware deployment, really helping your UI that you create to be more resilient to design changes. Also, you know, unique features, like I said, such as Storyboard's graphical compare and merge tool really enables your teams to remain in control of UI refinements throughout the entire process, as well as we work and we do extensive development and testing with our product to ensure that our Storyboard engines take full advantage of the specific board features such as proprietary graphic libraries or 2D or 3D hardware acceleration or memory management functions. That so removes the heavy lifting for you to have to do that. And that's one of the great things is that our engineers have worked with the folks at STMicroelectronics got the BSPs testing, and have optimized the runtime engines that you deploy onto the hardware to run that UI, really taking the guesswork out for you, so it's been all done for you. So that's one of the couple of the things that really makes Storyboard different. And at that point, I'm going to hand things over to Gary and let Gary kind of drive the rest of the demo.
The first thing I'll do is show you the Photoshop import feature of Storyboard. This is a very quick way of kickstarting your HMI design. It allows you to bring in the design features and assets from a Photoshop model and recreate that inside of Storyboard. So if I show you the design first, what we have here is something that's been created in a PSD file. It's in the form of a kind of a wall thermostat. So it's got 5 or 6 screens there. If I drill down into one of those a little bit more, let's look at the weather screen. You'll see that it's made up of a number of layers. Just locate the weather screen there. Number of layers that are stacked on top of each other. So if I, for example, hide the menu layer and the background layer, you can see how things are stacked up. That just leaves the middle layer. This is a very common way of doing things. It's how graphics designers go about designing UIs with tools such as Photoshop. So this is using a free online tool, Photopea. You don't need the full version of Photoshop to be able to use this import feature. We understand the file format ourselves inside of Storyboard and are able to take apart the PSD file and recreate it. So let's see that in action. So what I have here is an empty workspace. What I can do is bring in the new design from Photoshop, and here's the thermostat design we had earlier. This is set to be 480 by 272, the same size as the LCD panel on many dev boards. And what I'm going to do is create a new project. So this could easily be imported as extra screens into an existing application, but in this case it's a whole new project. And you can see here that all of those screens have been brought in. You can see here also that if I go into a thermostat screen, we've set this as the application start screen, and in this case you can see the layers recreated, so I can show and hide those as we could in the Photoshop world. So this menu here is something we'll be working with later on in an application development, but for the time being I'm going to hide that. And also you can see here at the bottom there are there's some icons here, the weather settings, the thermostat. These are going to be useful for navigating between the screens. Now we've got a more sophisticated design in mind, but for now what we're going to do is show just the overlays so I can click on them directly. So that allows me to add navigation features, so I'm going to add an action. Everything in Storyboard is triggered, and trigger is something like a touch in this case. We've got gestures and various other things. So a touch event is going to trigger an action of a screen transition, and whenever you trigger this event, I want to go to the thermostat screen, and I can quickly add this to the same thing to the weather and the same things to the settings screen. So again, touch, screen transition, and weather in this case. Finally the settings screen. So you can see how quickly it is to do this. We encourage the design teams actually to do this themselves. So Storyboard is designed to be used by both developers and designers, and it's pretty simple with a little bit of guidance to get this up and running. And it doesn't require much software development, if any. So let me save that, and what I can now do is run that as a simulation on my desktop. You see here I'm on the first screen, and I can navigate to my other screens here using the icons at the bottom, which I just animated. And what we've brought in also is some extra features inside of the PSD file. Based on some naming standards and notifications, we're able to make the make the behaviors of buttons and such. So there is a guide for this. There's a getting started quick reference guide for how you lay out the Photoshop side of things and some of the naming standards we use. But that's available on our website if you want to go take a look. So what I'll do now, just to save some time, is to flick to one that I've already prepared. So I've added some extra navigations, some other behaviors that make it a little bit more interesting and closer to a real application. What else to do while I'm here actually is that it's on the navigator view. We were looking at the model view, but on the navigator view we have all of our images which are in the Photoshop model are now been broken out and are assets within Storyboard that we can start working with here. You can see all of the individual components of the screen, and even looking at the piece of text in the middle here, we've brought in not only its position X and Y, but the value of the text, so I can change that on the screen, its font size, its color and position. So this is really quite a sophisticated import mechanism. We're not using bitmaps here. So if I run this, I'll show you some of the extra capability I added. On this screen, I use the plus and minus to not only limit the value, but also allow you to increase and decrease like you would in an application. You can also see just behind here there's an animation I've added to add a kind of a background glow that is blue if it's cooler, or red if it's warmer. And some simple logic to limit the value. So how I've done that is using some Lua scripting. Pretty straightforward, so very self-evident. You can see here there's a couple of functions. If I go to the actions view, you saw before we were doing the screen transitions using the touch. We've added a couple more here. So there's an action triggering on a touch to call a Lua function, when in this case it's decrease temp on the minus and increase temp on the plus, which calls these two functions here. So I'm doing some basic logic here to limit the temperature and also update a couple of the elements on the screen, which is the text value you saw changing. What I've also added is some animation, a custom animation to make the red and the blue glow. If I show you that very quickly, it's very simple here. We're choosing to create this dynamically at a runtime using the Lua command line features. And here we're going to create an animation, add a step and another step. So we're fading in and out, and this is kind of the glow and glow off feature. So that's all I've added really. We're ready now to take that design and export it to the target. So one thing that's most important to look at is in terms of the resources we have available. So we have now a metrics tab which you added in Storyboard 6.2, so 6.1. This allows us to look at the model and its impact on the target environment as we're going along. You can see here that several of the features in terms of images take up quite a lot of space here. So 500K of memory, the RAM is the background, and if I look at that on the disk, we'll see that it is something like 21K. So this is a native compressed image. So a PNG image is stored in its compressed format. So that has some implications. One of those is that although it takes up not very much storage space, it takes quite a lot of RAM space. So we've got to uncompress that and inflate that at runtime. And so we'll need some intermediary buffers and some processor cycles to do that. So this is something that you can look at from either an overall individual resource basis or indeed on each screen. So you can start to see which of the screens have the highest resource impact. So when we're looking at deploying this to a target, we're going to be exporting this model using our export configuration. And in this case, what I'm going to do, because I'm deploying it to a microcontroller target, is use our C++ resource header format. So this takes those model files, then those assets and script files, and represents them using our Storyboard virtual file system representation. What this is going to do is going to take those models, encode them in binary form, and lay them out using a structure. So to save a bit of time, I've already done that, and I can show you that file here. So that's going to export to then create this model file automatically. You can see here that here's the model, the storyboard model, and we've created a metadata and added that to the top, which is useful for revision control. And if I go to the very end, you can see here these are this is a virtual file system layout. This is the kind of the way that we're representing those resources in our header file as blobs. And you can see here's one of these resources represented as a character array. And so the virtual file system is very interesting. It's very lightweight and very straightforward. It means that you don't have to run a full file system on your microcontroller. So as part of the export, what we can do is look to optimize the way that we're deploying these. So if I switch back to the overview here, you see, unless we if we keep this as standard, we're going to be taking these compressed models and files and expanding them at runtime. So we're going to be taking up a relatively large amount of memory. This doesn't include the frame buffer size, so the number of pixels on the screen times the color depth. So that will be added on top of this as well. So we got 5 megabytes of SRAM and 1.2 of flash. So what I can do is create a custom export configuration. And this is a new feature in Storyboard we added quite recently. Here's one I've already created. So instead of using a file system deployment, I'm going to create a profile for virtual file systems, so for flash. And what I've been able to do now, instead of exporting in native format, I'm going to be exporting the files, the PNG files, in uncompressed form. And when I do that, you see here that allows us to reduce quite dramatically the amount of SRAM we're going to be needing at the cost of expanding them and storing them in their uncompressed form. So now we see the 5 megabytes is now on the flash storage. So this is how you can trade things off. You can actually even do this on an individual image basis. So you can choose maybe the background image and store that uncompressed or compressed. So that allows you really to tune the application target and really take those settings, and you can use those to bake in those decisions, optimizing and tuning for the amount of memory on your target board. And we've got a header file now, a resource that we can add to our C project and really get to work on the second part of the application, which is the engine and the integration steps. Now we have our model exported as a resource header file. We're able to start looking at how we integrate that with the target. In this case, we're going to be using a H745 Cortex M7 based discovery board, and we're going to be using FreeRTOS as the runtime environment there. I'm going to switch over to the project in IIR embedded workbench here, and here's the model header file that we created, and I've added that to the project just like any other resource. So it's now a header file inside the project. So along with that, we need to look at the way that Storyboard assets and libraries are integrated with your existing code. So this is a simple application. If I look at the main here, we really have only one task. So we're going to be creating a Storyboard main task. This would sit alongside any of your other tasks that you have in your backend code, but this is a standalone application here. And really, it's very simple. We're using all the standard STM32 cube drivers and setup screens, so setup code. So we're really building on something you've already got. And you see here that we've pulled in a whole bunch of drivers and HALs from the standard STM32 cube. So in terms of storyboard integration, we have a file here called the SB Engine task file that we give you a template for. And really this is again very simple. We have the main task, which is literally going to launch the application to kickstart Storyboard, and this is going to be loading up, in this case, Storyboard libraries, which are added in the form of static libraries. Here we have a whole bunch of them. These are very much the constituent parts of Storyboard. So everything is a library and a plugin. So if you're not using a particular feature or a library, then you can remove it to reduce flash space. In terms of integration, we've got a main task that kicks off the model. Very shortly after that, you'll need to spin up maybe one or more tasks to do the input. So we'll run this asynchronously with the main display task. And here what we're doing was sampling the touchscreen state. And that's going to be raising events here to send into Storyboard, just as we were looking at previously. The touch events are comprised of a press and release and motion. So those are the raw materials for our user input. And in terms of the application, if I show you how it's integrated, here we're looking at some setup code, initial configuration for the LCD, calling standard BSP functions here to set up the touchscreen and the physical LCD interface. Here we're using another function which is called back from Storyboard to allow you to customize the frame buffer and display formats. And also, in this case, we're using the DMA2D features. So this is the Chrome Art Accelerator. You see here we're configuring it and setting the begin and end for the transfers for the frame buffers and also the screen dimensions and color format. So that's all pretty much template code. Very little code to add on top of your application. So what I'll do now is I'll run this on the board, which is already pre-flashed to save a bit of time. So if I show you the board itself there, I'm going to launch that on the target, and you'll see the user interface that we designed earlier is being flashed, downloaded, just the debugger setup there, and we should be able to run that on the target board and show you it in operation. Okay, so you can see here we got our animation with the surround with our flashing. We've got plus and minus there. We're able to navigate between the screens. Performance really is very good. The Chrome Art acceleration is pretty impressive, and yeah, so that's Storyboard running on the MCU target. So for the next stage, perhaps if you consider you have a requirement where an entry-level version of a product would be based on a microcontroller, an MCU, perhaps maybe a more premium, a high-end, top-end version of our product would perhaps have a larger display, and maybe it has got some extended capabilities, maybe some connectivity, internet access, that sort of thing. So in this case, you're going to be looking to uprate or upgrade the application performance. I'm going to be using something a bit more powerful. So here we have an MP1, a STM32 MP1 based device. This is Cortex A7, an application class processor. And in this case, we're going to be making use of Linux. So this allows us to leverage all of the operating system features and functions that you get for free in Linux, such as connectivity and also more advanced drivers and graphics capabilities. So if we switch back to Storyboard, the first challenge really is to look at the scalability, the scaling requirement. So before we had our application designed for 800 by 272. we're going to be needing to use 800 by 480. So the first challenge is to resize or rescale the application. So one way I can do that, I'll show you quickly, is to copy that application, and I'm going to make a clone, which is 800 by 480. I'll call that resize. Okay, so that's going to make a second copy of that project here. If I close this screen model here, open this one. So here's the same model we had before. If I go to the properties, you can see here that we have a capability to resize automatically. So this is a hugely important time-saving tool inside of Storyboard. We've learned from some of the challenges our customers had that resizing and rescaling an application is a very tricky thing to do if you're moving every pixel manually. So we built a migration or resize wizard. So I'm going to create a second version of my models and assets. I'm going to call that 800 x 480. And here I'm going to resize and scale it. So we're now going to be moving 480 to 800 and 272 to 480. Okay. So you can see here that it's 166 versus 176%. So it's not any exact form factor or exact aspect ratio change, but it's close enough for our purposes here. So what we can do now is flick back to our application, and here we've created a new version, a new model of the application and all of its assets recreated within Storyboard, and that's now resized and scaled. It may not be easy to see, but the zero, the circles are slightly elongated, but for first use case, it's pretty good. And if I run that, what we've been able to do is resize and rescale that application. We could also reskinned it as well with a Storyboard re-import of a Photoshop model. But what we've done is crucially retained all of that logic, all of that behavior that we added before. So the navigation logic we created, and also the animations. So all that has been scaled automatically for you, and it saved a huge amount of time. So now what we're ready to do is deploy that. So what I've done here is I've got one already set up. Okay, I'll just reopen that one. And if I show you the target board itself, so what we have here is the MP1 dev kit running our standard demo, which you can download from Storyboard website, so from Crank Software. And this basically is quite a nice demo. It's got multiple features as a home automation application, and as a kind of a front end menu, that's allowing you to navigate around and run a few demos. So what we want to do is replace that application with our new one that we've just created. So with Linux, you're now deploying in a different way. So what I can show you is the second way of deploying. So we're no longer using an application header file. So we're using a file system. So the individual files and assets that we saw in the file system view and the navigator view, we're able to deploy that not only to a file system, but also using an SCP transfer to the target board. So this is using an SSH link. It's going to deploy all of the files in a folder onto the target file system, and where we're going to execute a script file, which I'll show you shortly, that launches that and runs. So what this will do is kick off the transfer. Is copying down all of the files, so you'll see basically deploying to the target, so that each file and asset is deployed. And now you can see on the target here that same application we've resized and rescaled is running on the target. So this is instead running on the Linux OpenGL version of our runtime. You can see here we've got our navigation and our behavior. So we've able to take that application, resize it, rescale it, redeploy it onto a completely different runtime. So just pulling up some connections to the target now. You'll see here that I have an SCP file view of the target, and in this case we've got two different runtimes there. So I'm running as default the OpenGL version of our runtime. So we've got an application running. If I type top on the target here, we'll see that actually Storyboard is not doing anything until we actually move or make it kind of behave. So this is the event-driven stuff, and even then we're still like a very low utilization. So we're not using lots of CPU cycles. To really show the scalability of Storyboard, I've got an application which has been modified to run both with and without some 3D behaviors. So if I flick over to Storyboard, I'll pull this application in. It's something we put together a little while ago to demonstrate a white goods type of application. So in this case, it's a recipe oven. So I'll pull it in now and I'll store that in an archive. So if we look at the project itself, we've got two versions of the application. One is using 3D and the other one is a 2D version. So the differences are actually subtle, but if I show you it running first on my desktop, I'll kick that off here. What we have here is we're using kind of a collapsing rotating effect, and that uses one of our 3D control options. So this is requiring some of the GPU. And if I show you the same application but running in 3D mode, we can see here that we've lost the rotation, but we can still do the graphics and the behaviors almost the same, but not quite using the high-end requirements of the GPU. So what I could do, I'll just show you this running on the target board. If I deploy that for you, let's pull up the target board as well. Okay, so we're going to deploy that again just as we did before. We're going to be using the OpenGL acceleration version of the runtime. I'm going to deploy that. Hopefully you should see that replace the demo we have. This application's got quite a few additional images, so it takes a little longer to download, but you can see here that the application is running quite nicely. We've got our 3D spinning effects on the target board. Oh, I just closed that one. Let me run it again. One of the features we have here is only copy the changed or missing files, which is quite useful in this case. So I'll download it again, and this time it should come up pretty quickly. So we've not changed anything. Tap on the screen. You see here we got a rotating menu. This is really quite high performance, really interactive user interface. Okay, so that's really all I wanted to show you now. Some nice features there. This is just a way to illustrate the range of features you can use, all the way up to 3D accelerated graphics and some quite rich user interfaces. The fact that this is all in Storyboard and we've been able to do this without writing code allows you to really scale up or scale down and leverage your investment in developing with Storyboard in your application in the first place. So I hope that's been interesting, and I think we'll leave it there.
Back to my presentation. All right, so just to kind of wrap things up, just to kind of drive home some of the great points that Gary spoke about. Definitely when it comes to Crank Software Storyboard, and more specifically for the STMicro STM32 product lines, definitely it really kind of provides a single tool for your UI development, regardless of hardware. Like we talked about, that you can easily scale up from the MCUs, from like say the H7 to the MP1, or easily scale down from the MP1 down to something like the H7, really allowing you to easily create. If you have a product line that has, like Gary said, a low end and a high end unit that wants to leverage maybe the powerful but cost effectiveness of the STM32 MCUs, or maybe some of the rich 3D kind of capabilities of the MP1, you can easily do that with Storyboard.
Also, it's that the collaborative workflow, like I talked about, that decoupling of the front-end UI design from the back-end development, back-end logic, really allows you to really kind of have both your designers and your software engineers, working together in this collaborative workflow, allowing them to really kind of fine-tune the user experience that you want your product to have within the UI, and then easily being able to adapt to it at any point in time. Again, with that, like I talked about, the flexibility that it really provides for your UI to not only kind of scale, but to kind of port, to change out at any point in time, different points of the technology stack that you may have, that really allowing you to have that smooth, intuitive kind of rich performance. And then, of course, when it comes down to it, easily kind of leverage the low memory footprint, whether it's low RAM, flash footprint that is offered across the MCU lines. We support a wide variety of RTOSs or OSs, and of course you have that simplified development process, so really removing the need for compiling and cross-compiling that can really lead to some time-consuming cycles that kind of sometimes produces an unappealing workflow that requires specialized expertise that can really add to the overall cost of the projects, but also adds on time and complexity where you don't necessarily have to need that. So definitely, like Gary said, we have a variety of demo images that are available for a variety of the STM32 boards. Can be all accessed at cranksoftware.com. So definitely go and check it out today, whether it's for the H7 all the way up to the MP1. Also, we do offer a 30-day trial of Storyboard, and the great thing about it, it isn't watered down or restricted. It's the full suite that you get access to for 30 days, so you can really kind of kick the tires on it, get a feel for it, import some of those demo images onto maybe some of the eval boards that you're currently evaluating from STMicroelectronics for your next project, and allowing you to kind of get there and tweak and see about what works for you. So definitely some key takeaways before we jump into the Q&A for today is again, give it a download, give it a try. You can find it at cranksoftware.com, full featured access. You get access to the Crank Software demo images, but more importantly, we also have a help center that's there to provide you with some additional learning. So you'll find some getting started videos, you'll find a wealth of knowledge base articles, and much more at support.cranksoftware.com. So definitely, throughout the process, if you are going to evaluate, jump into our help center, because it's just a lot of tools that really kind of get you started from the basic. And we're also offering up some advanced user training that's also accessible from our website as well, really allowing you to kind of take your knowledge and your ability to develop UIs that are scalable and able to really perform in an optimized environment for the the STM32 devices today. So thank you very much for your time.